Okay, in this lesson we're going to talk about the substitution method. It's a method to algebraically solve equations, aka without graphing them. Okay, and what we're going to do is let me write down an example. So let's do y equals 6x and x plus y. Sorry, let's fix that. Is equal to 28. So if this system of equations were graphed, I would graph a line, 2 lines, and I'd first have to solve them both for y equals so that I can graph them using y equals mx plus b form. But rather than do that, I can do it much easier algebraically. And look at the first system of equations. You have y is equal to 6x. Now, if we know what y is equal to, then we can take what y is equal to, in this case 6x, and we can plug it in where y is. So I'm going to rewrite the second equation, but I'm going to plug in, instead of where y is, I'm going to plug in 6x. So now the new equation becomes x plus 6x equals 28. And I know that's true because I already know what y is. And then I just solve this and I can find x. So x plus 6x is 7x. And then if I just divide both sides by 7, I'll get x is equal to 4. Now if I know what x is equal to, I can find what y is equal to. So I'm going to take this and I'm going to plug it back into the original equation. And I pick, it doesn't matter which original equation, you can pick the top one or the middle, the second one there, the middle one. I'm going to pick the top one, and simply because it's already solved for y, and I want to know what y is, so I'll just plug in 4 for x. Notice when I plug in, I put the quantity in parentheses. So here I did 4 in parentheses. Here I did 6x in parentheses. The reason for that is if you're plugging in a binomial, you're going to have to distribute. And so I find y is equal to 24. So if I were to graph this, these two lines would cross at the point 4, 24. And it's useful to use the algebraic method because when I graph this, 424 is not a number that often falls on a coordinate plane. Alright, let's try one that's a little bit more complicated, or I guess we should say more complicated looking. Let's do y equals negative x plus 5 and y plus 4x equals 5. Again, this one lends itself well to substitution because one of the equations is already solved for a variable. In this first equation, y is solved for negative x plus 5. So we know that y is equal to negative x plus 5. So I'm going to take this quantity and plug it in where y is. So let me rewrite this expression. Negative x plus 5 whole plus 4x equals 5. And I put the parentheses in this case we don't have to distribute anything. And then I can drop the parentheses and add like terms. So negative x plus 5 plus 4x. I'm going to add the x's together. 4x minus x is 3x plus 5 is 5, so I'm going to subtract 5 from both sides. 3x is equal to 0. Divide by 3 on both sides. 0 divided by 3 is 0. So in this case, x is equal to 0. Now I'm going to take my x, plug it back in, and find my y. It doesn't matter, it does not matter which equation you pick again. I'm going to pick the second equation. And I'm going to plug in 0 for x. So x is 0, y is 5, so these lines would cross at the point 0, 5. And that is the substitution method.